Good day everyone. Today we're going to discuss an introduction to balancing chemical equations. These are our objectives. Infer how to balance a chemical equation using a simulation application and interpret a chemical reaction in terms of number of particles. For the activity, download the simulation app from the link. After downloading, open the app and click Introduction. For tools, select the bar graph icon, and for the reaction, select Make Ammonia. Adjust the numerical value or coefficient of the reactants and product by clicking either the up or down arrow. Your goal is to make the equation balance. Once the equation is balanced, the unequal sign between the reactants and product sides becomes equal. If you want to clear your data or restart, click the icon. This is the interface of the application. For the tools, select the bar graph image. For the reaction, select Make Ammonia. We can see here the reactants and the product. This is the chemical equation. It shows the reactants undergo a reaction to form a product. In this case, we have nitrogen reacting with hydrogen, forming ammonia. Before the chemical symbol or formula, we can see a number which we can adjust by clicking either the up or down arrow. This number represents the coefficient or the number of particles or the amount of the substance in terms of mole. Let's say 1 mole of nitrogen reacts with 2 moles of hydrogen to form 2 moles of ammonia. In the boxes, we can see the particle representation of the reactants and the product. We have nitrogen with 2 atoms and hydrogen with 2 particles in 2 units. That is, 2 hydrogen as denoted by the coefficient number 2. On the upper part of the boxes, you can also see the number of atoms of nitrogen and hydrogen, both at the reactant side and at the product side. At the product side, we have 2 units of ammonia. N is represented by the blue particle, while hydrogen is represented by the white particles. In every unit of NH3, we have 1 atom of nitrogen and 3 atoms of hydrogen. As denoted by the coefficient number 2, we have 2 units of ammonia. However, looking at the top of the boxes, the number of particles at the reactant and product sides are not equal. At the reactant side, there are 2 atoms of nitrogen and 4 atoms of hydrogen. At the product side, there are 2 atoms of nitrogen and 6 atoms of hydrogen. In any chemical reaction, the mass of the substances is conserved. Hence, we need to balance the number of atoms at both sides. Counting the number of atoms on the upper part of the boxes, we can see that we have 2 atoms of nitrogen and 4 atoms of hydrogen at the reactant side, while at the product side we have 2 atoms of nitrogen and 6 atoms of hydrogen. We can change the number of atoms by changing the coefficient. Since the number of hydrogen is not balanced, let us try to change its coefficient. Now, let us count again the number of atoms at both sides. At the reactant side, we have 2 atoms of nitrogen, and at the product side, we have 2 atoms of nitrogen. We have 6 atoms of hydrogen at the reactant side, and at the product side, we have 6 atoms of hydrogen. Since the chemical equation is now balanced, the not equal sign is now changed to equal sign. Follow the same procedures for the reactions. Separate water and combust methane. After the activity, submit to me the balanced chemical equations for separation of water and combustion of methane. For your assignment, describe the following types of chemical reactions and give one example for each. Letter A, combination reaction. Letter B, decomposition reaction. Letter C, single displacement or substitution reaction. And letter D, double displacement or metathesis.